What if it's too hard?
I'm gonna push you.
What if it's too long?
I'm gonna push you.
What if it's too tough?
I'm gonna push you.
What if you're just too young?
That's not true.
What if you're not good enough?
That's not true.
Why? Because
I can do anything I put my mind to.
I believe in you.
Chin up
Believe in yourself.
and high.
Tell me why.
We push through anything we put our mind to.
Now we're gonna move on to we're gonna move on to empty or null set. Let me see how much time I have. Okay, good. So empty or null set. So a set without members is called an empty or null set and is denoted by the symbols. Let me see the bracket or braces here, which is an empty pair of braces, or this symbol here, a circle with a slash, all right, or a circle with a diagonal line, all right, circle with a diagonal line, all right. So yes, all right. So these two symbols represents empty sets, all right. So a set without members is called an empty or null set and is denoted by the symbols. And here's the symbol. Here's one symbol, which is an empty pair of braces, nothing inside it. Or we have a circle with a diagonal line drawn across it. So this is also a symbol that represents an empty set. All right, nothing in there, empty. Let us give you an example of this. I'm going to give you an example of an empty set. So call this set set Q. Call it set Q. Call it set Q. All right. So set Q is a set, the set of odd numbers less than 10 less than 10 rather, and exactly go down here, it can't hold there, and exactly divisible. Divisible mean divide, all right. I mean it can be divided by. Oh, I'm writing divide. All right, divisible. Sometimes I talk what you write, you know. So exactly divisible by 2. I'm gonna close my set with my curly bracket or braces. All right. Now set Q equal a set of odd numbers less than 10 and exactly divisible by 2. Now, is this set an empty set or a null set? Because empty and null is the same thing. All right. So if they ask you what is, give an example of a null set, it's the same thing. They are asking you to give example of an empty set. Empty, null, same thing. Null, empty, same thing. All right. Don't be confused. All right, good. So set Q is a set of odd numbers less than 10 and exactly divisible by 2. Can this set be represented? No, thank you very much. It cannot be represented. So therefore, this set is an empty set. All right, this set is an empty set because there are no or there is no number that fit this description. No number that fit this description or that description that they're asking of. Set Q is a set of odd numbers less than 10 and exactly divisible by 2. There's no number that fit the description. All right? Because you cannot say that the odd number can exactly or odd numbers can be divided exactly by 2. No, odd numbers cannot be divided exactly by 2. It will give you a remainder. Odd numbers will give you a remainder. So it cannot be exactly divided by 2. It will give you a remainder. Remember we say that even numbers, if the number is not even, they are odd. All right, they are odd, I should say, not odd. They are odd numbers. All right. So if the numbers are not even, they are odd numbers. So therefore they are divisible by 2, leaving a remainder of 1. So this set is saying that a set of odd numbers less than 10 and exactly divisible by 2. It cannot be exactly divisible by 2. It will leave a remainder. All right. Just want to clear up that so that you get a perfect understanding of what I'm saying. All right, good. Now let us look at on a next or another example of empty set. Now this is a set. This is set W. Call it set W. All right, we're gonna call it set W. Set W is equal. I'm not gonna write out this. So I'm just gonna put the set there and I'm gonna put those two words. All right, German and I'm gonna just and I'm gonna put the next word speaking. All right, can't write out everything. All right, it will take up a lot of time. All right, so speaking, even though learning to be very concise here. All right, so set W equal a set of German speaking Caribbean country. All right, set W equal a set of German speaking Caribbean country. All right, set of German speaking Caribbean country. I'm not going to write out a set of and all of that. Just put the German speaking in the bracket here. All right, so I'm going to read out what the set is. Set W is a set of German speaking Caribbean country. Is this a null set? Yes, it is a null set. It is empty. It is an empty set. All right, it is an empty set. Why it is an empty set? Because there is no German speaking Caribbean country. So therefore this is a empty set, or we can say we can put the symbol to represent it. Same thing with here. You can put the symbol to show that it's an empty set. All right, it's an empty set. So set W equal set of German speaking country, empty set, empty set. All right, there are no German speaking Caribbean country, so therefore the set is empty. Beautiful. Let us continue. All right. All right, good. I'm recording. So we're moving on to equal sets. Now, two sets are equal if they both have the same number, and I want you to pay attention carefully to this because this always mess students up. Now, two sets are equal if they both have the same number of members, even if they are arranged in different orders. And look carefully on the symbols, please. So the symbol, this right here, this equal sign, denotes equal sets, while the symbol, this equal sign with a diagonal line drawn across it, denotes not equal sets. Let me read from top again. Two sets are equal if they both have the same number of members. All right? Even if they are arranged in different orders. All right? I should say, uh, so let me repeat. Two sets are equal if they both have the same number of members, even if they are arranged in different orders. All right? So we're going to look on an example of this definition. So let us go. All right. I need to change my board. All right. Fresh and clean. All right, good. So an example of this would be, let's call this set P. All right, let's call this set P. I'm gonna call this set P. So set P is equal to, put my braces, and close my set there. So I put my comma between the letters. Always put a comma between your letters. All right, so I have set P equal uh, a set of letters. All right. So is this set equal? This set cannot be equal unless it have something to compare to. All right. So let us have a next set now to compare the set P here. Let us have a next set to compare set P. So we have set, call it set A. All right, so we're going to compare now. We want to know if these two sets are equal. All right, so we have O, we have C, we have F, we have R, that's R, no, or that's R, and we have E. All right, good. So we want to know if these two sets are equal, set P and set A. Now, in set P, we have F. In set A, we also have F. All right. In set P, we have O. In set A, we also have O. In set P, we have R, and in set A, we also have R. In set P, we have C, and in set A, we also have C. In set P, we have E, and in set A, we also have E. So therefore, they are the same. They just rearranged differently. All right. The letters are the same, but they are just rearranging, or they just rearrange differently. So this word spelled force, or these letters spell the word force, they just rearrange the letters differently. All right. Just ensure that they are the same. All right. They must be the same to be equal. All right. Must be the same. to be equal. If they are not the same, they are not equal. And we see that we have the same letters in set P and the same letters in set A. Remember class, for the set to be equal, they must be the same. Set P must be the same as set A. Set A must be the same as set P for it to be equal. If they are not the same, they are not equal. All right, I guess you all get that. All right, good. So I can say now that set, we can say that set P is equal to set A. All right, set P is equal to set A. Okay, so these two sets are equal. All right, let me give you a next uh, example and let me see if you understand. All right, so this can stay. All right, so I'm going to call this set y, set y equal, I'm going to call this one set, we have to have two sets to compare, all right, to see if it's equal. All right, so we have set k, call this one set k. I think this t is too long. All right, good. So we want to call this set k, and set k is equal. We're going to put in the elements now, our members, all right, of the set. So the elements for set y are 17, 19, 23, 29. So these are the members or elements of set y. Now the elements or members of set k are 29, 23, 22. All right, so number 22, then we have we can say 17. All right, 17. All right, good. So look on both sets and tell me if they are equal. And if you say that they are equal, you are so incorrect. Yes, you thought that I was going to say correct. No, you are so incorrect if you say they are equal. If you say they are not equal, then you are indeed correct. Now, if you look on both sets, in set Y you have 17, in set K you also have 17, in set Y you have 19, there is no 19 in set K. Set Y 23, set K also contains 23, contains 23, 29 in set Y, 29 also in set K, there is no 22 in set Y, but there is 22 in set K. So therefore, this set is not an equal set. This set is not an equal set. All right. So remember that if a set is supposed to be equal, or if the set is going to be equal, the elements or members of the sets must be the same thing. It must be the same. So all the numbers that are here in this set must also be in this set. All the numbers in this set must also be in this set for it to be equal. All right. So an equal set must have the same members or the same elements for it to be equal. Always remember that, class. All right. Never forget that. All right. Moving along. Oh, all right. Let me before I move along, let me just write this, that set y is not equal to set K. Alright? Set Y is not equal to set K. This is what it means. Set Y is not equal to set K. Alright? Alright, let us move along. Right along, right along, right along. So we're going to look at equivalent sets. So we're going to look at equivalent sets now. Alright, so when two sets have the same number of elements or let me read that over. When two sets have the same number of elements or members, then the sets are said to be equivalent. So when two sets have the same number of elements or members, then the sets are said to be equivalent. Now the elements or members shows one-to-one correspondence. One-to-one correspondence, all right? It shows one-to-one correspondence. I should explain all of that. Now the symbol here represents or denotes, this is an arrow, so the symbol here denotes equivalent sets, and the symbol here with an arrow and a diagonal line drawn across it means not equivalent. All right, so let us do an example of this. All right, let us do an example of this. Let me draw a line here. So this is my board that I'm working with now. This part I'm working with now. All right, good. So how much time I have? How much time I have? Good. All right, good. An example of this, I would call my set H. So H equal P A G and D. All right, and I would call this one, so I would call it set F. All right, so F equal Q S F E. All right. All right. Let's go back to the definition quickly. So equivalent set, it says when two sets have the same number of elements or members, then the sets are said to be equivalent. When two sets have the same number, remember this word, number. Let me highlight it. Number. All right. Let me say it again. When two sets have the same number of elements or members, then the sets are said to be equivalent. All right, and the elements or members shows one-to-one correspondence. G. All right, so G is equal to 0. Let me put not 0. Let me put these are mangoes. All right, mangoes. These are my mangoes. Let me change it up. Mangoes. These are my mangoes. All right. So I have 1, 2, 3, 4, 5, 6 mangoes. All right, and this set now I call it P. Call it set P. All right, and in this set I have bananas. And my bananas. Wow, beautiful bananas. Ready for the monkey. All right. Good. So I have my bananas. All right. So in one set I have, in set G I have mangoes, in set P I have bananas. All right. Good. So you are going to look at these two sets. You're going to look at both sets and tell me if they are equivalent. And if you say that they are equivalent, that means you are so incorrect. They are not equivalent. All right, they are not equivalent sets. All right, set G has or have 1, 2, 3, 4, 5, 6. Have six elements or members in it. Set P have 3. All right, 3 elements or members in set P, 6 elements or members in set G. So remember now, an equivalent set must have the same number of elements. So these two sets don't have the same numbers of elements. All right. The elements don't have to be the same, but they must be the same number to make it an equivalent set. All right. So we can say that these two sets, or both sets, are not, or G is not equivalent to P. All right. So set G is not equivalent to set P. All right. Good. Okay. So we're moving right along. All right.